In this video I'll try to go a bit more into the details of my dinosaur costume. It's not a tutorial, but more like some inside information on the structure and the mechanics. I hope this helps those of you working on similar projects. I made a few upgrades since my last video. The most notable are the speaker and the foam over its spine. But let's start by taking a look at the materials and how I use them. So the main materials are PVC and foam. Foam for the appearance and PVC for the structure. I used a combination of 5/8" and 3/4" pipes. By heating the material you can bend it around another pipe, thus creating either a joint or simply a way to attach parts perpendicular to each other. I used separate bended parts for the attachment of the pipes, because it makes it easier to get the right length, reuse materials and sort of build with the pipes to see what works. At first I used duct tape to keep everything together, but once content I attach parts permanently using either glue or screws. For the appearance I chose to go with foam plates. They keep it simple but add just enough detail to create the shape of the Raptor. So here's a drawing of the basic frame. This is the side view and this is the top view of this bottom part. At the left side the neck gets attached and at the right side the tail. These 4 points can rotate, thus creating a little bit of a seesaw in which I am the fulcrum. This is the part that goes over my shoulders. I started with 2 pipes on the front and 2 on the back, but as I built further the frame became a bit unstable, so I added 2 extra pipes on both sides. I put some isolation pipes around it to make it a bit softer for my shoulders, but because of the diagonal pipes, most of the weight is actually on my hips. And in a way it's a good thing, because it spares my back, but I just have to watch out that I don't end up with too many bruises on my hips. So the frame has a few critical points that have to hold a lot of force. The most critical are probably the attachment of the neck and this front pipe. The back part is less critical because the tail is attached here and it pushes this pipe backwards, thus creating more of a balance. So these pipes are just to increase the strength and create a better shape of the chest. Here's where the legs get attached. The last important part of the body are the 2 pipes at the sides, which I use to place the costume on the ground. I wanted the head to be able to move left and right, up and down, and to rotate. And on top of that, I needed the neck to be able to move dynamically with the head to make the movements more natural. This is the front part of the body where the neck gets attached. The neck consists of 3 pipes going through a hole in a conduit box. They are attached with some rope to prevent the pipes from shoving further down, but the rope allows the positioning of the neck and it also allows a slight rotation of the neck, thus resulting in the head tilts and the head shake. The side of the head is heavier than the side of the steer, but I used an elastic rope to standardly keep the neck up and the steer down. I can still move the neck down, but I have to deliberately move the steer up. At both ends of the neck I used the same 2 joints, but sort of mirrored horizontally. The first joint is to move the head up and down. There's a rope attached to this part going through the top pipe of the neck to the steer. The second joint is attached to the first and is used to move the head left and right. I cross these ropes. Left is attached to the right side and right to the left side. It makes it a bit easier to control the head in combination with the positioning of the neck. For the mouth I used a brake cable because of the casing. Not all of the joints are at the exact same spot, and I didn't want the mouth to be influenced by the position of the head. Fixing both ends of the casing allows flexibility in the middle. These are the joints of the mouth, and here goes the brake cable. And the casing is stuck here and here. The mouth opens automatically due to an elastic and closes when I pull the handle on the steer. Maybe it would have sounded more logic the other way around, so I wouldn't have to hold the mouth closed deliberately. But this way I have more control over the force I use, which is very nice if I actually want to hold something or pick up an item. But I still didn't want to constantly close the mouth, so I put a screw here that can keep the handle in place. The legs are just pairs of pipes with joints in between. An elastic attached to the side of the body pulls the heel up. The knee and the heel can be attached to the body frame. The paws are attached to my shoes. I put a layer of duct tape around the pipe under my shoe, so it won't damage when I walk on stone or asphalt. The rope makes sure the toes can't bend too far down. The elastic makes sure the toes return down after bending upwards. The arms are pretty simple. They consist of one pipe with a joint. The only thing worth noting is that I can pull the arms up before placing my chest on the ground. Here's a drawing of the tail. The rope here helps keep this part of the tail in a vertical position. The tail is still detachable. This pipe goes inside the top pipe of the body frame. These two attach to the side of the frame and these to the bottom. The tail can bend at these two spots where I use a bit of garden hose. It returns back to a straight position because I put a fiberglass stick inside the tail. So the last part to talk about is the speaker. This thing is normally attached to my steer. There's a Raspberry Pi with Pi hat on the back side. It's attached to a 12 ampere battery and a JBL speaker, which is normally placed inside the chest of the Raptor. I wrote this simple Python program. It basically reads the button pins and plays a random sound from a selection of MP3 files. I placed the line in the RCA local file, so the program starts running whenever I start up my Raspberry Pi.